Hi everyone, very welcome to InfoSecTrain, and today is the last day of our CCNA accelerator, right? So we have learned many of things from in CCNA. Now the last day we were discussing about security, so now we are moving on to the security terminologies. So there are some terminologies in security that you should know and that you should be aware of. What is security terminology? First thing. So let's start with some basic ones, right? The terminologies. Now, when we are talking about security terminologies, the very first one is vulnerability. What do you guys understand by vulnerability? So, vulnerability is what? Any flaw or any weakness in a system, right? By which unauthorized user can take the access of your software, of your network, of any environment of yours. They can get inside your environment and get the information or get or steal your data, right? So the weakness they are taking advantage of, that weakness is known as vulnerability, right? Great. Then there is exploit. What do you mean by exploit? So exploit means taking advantage of the vulnerability, right? Then there is one thing which is known as attack. What is attack then? So taking advantage of a loophole or weakness is exploit, right? But when I'm saying attack, then what it is? Now, attack means that the path attacker is taking to exploit a vulnerability. The path, the way attacker is taking advantage of a vulnerability, that way is known as attack. So, let's say DOS, denial of service, that is an attack. That is a way to exploit a weakness. Now, the weakness was that rate limiting was not there in the organization. So, it was exploited by the attacker, right? So, that is what? That is attack, right? Then next thing that you should know is payload. What is payload? Now payload in simple terms of networking, it means data, right? Any data that you are sending and any data that someone is sending to other person, that is payload. But when we are talking in terms of the security, right? Payload is what? Payload means that it is a malware or a piece of code that helps uh, the attacker or pen tester to take the access of the system, right? Now let's say there is a payload with the name Windows slash Meterpreter slash reverse underscore TCP, right? So by the name it is showing that the name of the payload is Windows and it will give a reverse TCP connection to me, right? The payload which I'm sending is the Meterpreter. Meterpreter is the whole payload, right? So that is how the payloads they look like, right? So in simple terms, I can say payload is something that supports your exploit, right? Then next is asset. What do you mean by asset? Something of value to organization, great. So anything which holds some value for you or the organization, right? Assets are of two types, tangible and intangible. What is tangible? What is intangible? Okay, physical assets, IT server. So tangible means anything that you can touch or feel. That is tangible. Intangible means anything which holds some value but you cannot touch or feel it. Like your data. Tangible means like your laptop. Maybe your laptop is an asset for you, right? It holds some value for you. So that is tangible, right? Your data is inside your device. It's very useful and it's uh, an asset for you, right? But you cannot touch or feel it, right? Then there is one asset value. What is asset value? So asset value means you define your assets. Let's say you have multiple assets. Now you will be prioritizing the assets. Which asset has more priority, right? So let's say there is your laptop and mobile phone, right? And one of them is at stake. Let's say someone is running with your mobile phone and laptop. So you have to choose one only. Which one will you choose if you have to save only one, or if you can save only one? Correct. So it depends in which device you have more data. So it depends on the data that you have. Like if you have some personal, like nowadays mobile phones have more personal information of the people, right? So mobile phone has more priority as compared to laptop. If it is your office laptop, it must have remote wipe feature enabled. So remote wipe feature, you will remotely wipe your device and done, right? Then there is hack value as well. Now hack value means that what I'm doing, so you define your assets on the basis of some value, same like that attackers they define your assets on the basis of some priority, right? So if let's say there is one bank and one a newspaper website, so attacker will go for bank for hacking, right? Because they have some, they will get some money, right? That is hack value. Then next one is risk. I'm holding a glass of water over my laptop. Now the water may spill over my laptop, it may not, right? That is risk. There is a risk. And if we talk about share market, there is a risk, right? Then there is a external router in the organization. Now the router is bit old. The operating system of the router is also old and it's not getting any updates. There is risk. If power backups are not there, correct? So power failure may happen for the organization. That is also a risk. It may happen, it may not. If it's not, we are not sure it will happen, but it may happen or it may not, right? So that is risk, right? Then there is threat. What is threat? So when we are talking about threat, threat means anything which can lower or alter my asset value, right? So the last example I took, the router in the organization, or let's say in the DMZ. Do you guys know what is DMZ? DMZ stands for demilitarized zone, right? This is the zone in which is out of the internal network but still inside the firewall, enterprise firewall, but it will help you in doing what? In hosting the web servers or file sharing servers or anything you want to give public access. That is DMZ, right? Now, let's say there was a router inside DMZ and that router got compromised, right? So the website will be down, right? Or that router got failed, right? There was a risk got positive, and then router got failed. So it altered the organization's availability, right? So the website is not available for the customers, so they are not able to purchase anything. That is threat, anything which can change the value, right? The attackers, they are always threat for the organizations, right? They can alter the value of the organization. Now there are different types of threats, right? Like there are environmental threats as well, right? Environmental threats means like if you have an office in on ground floor, right? And flood situation came, right? Then earthquake zone, uh, prone to fire zone, right? So that is also a kind of threat, right? So while building the organization, while purchasing offices, all the organizations, they take care of these things as well, where the office should be, at what floor, and what can be the risk if hurricanes or any storms or flood situation happens, then how we will deal with it. All these things should be checked. Software performing repetitive tasks is bot. Great. So when we are talking about bot, we can define it anything which is commanded and controlled by someone else. That is bot. And a network of these type of devices is known as botnet, right? A network of bots, right? Then next thing, have we heard of cleaner or wiper? So what it does, when I'm saying cleaner or wiper, it means that it will clean up or wipe out data from your device. So after hacking your devices and after stealing the information, so what attackers do, they tend to wipe out everything from the systems, right? That is cleaner or wiper, right? Then next thing is daisy chaining, right? What daisy chaining means, so when we are talking about daisy chaining, the devices connected in a a network of compromised devices, right? Where attackers took access to one system, then another system, then other system, and like that, attackers took the access of all the systems, right? That is known as daisy chaining. Perfect. The next one is known as PII. What is PII? What it stands for? Personally identifiable information, right? Now, what personally identifiable information is? Data which can connect to a person. Yes. So, personally identifiable information means when we are identifying a person from its attributes, right? Let's say my passport, right? Passport has personally identifiable information. Anyone can identify me by looking at my passport, right? Your date of birth, your citizenship, anything, right? Emails, that is also a PII, right? Then next thing, it is zero day vulnerability or exploit. Correct. Any vulnerability which is not, which is exploited by the attackers, but the organization who did the development of that software is not aware that which vulnerability was exploited, right? So they don't have any information. That is what, that is zero day vulnerability or exploit. Perfect. So these are some of the security terminologies that you should know, right? Now the next thing is we'll be talking about some common security threats, right? Now what are the threats, right? So because modern enterprise networks are, they are made up of many parts that all work together, securing them is a very complex task, right? So, as with a simple box analogy, you cannot effectively try to secure it until you have identified many of the vulnerabilities, assessed the many exploits that exist, and realized where the threats might come from. Only then can the appropriate countermeasures and mitigations can be put in place, right? Now, you should also consider some of the most important attributes of enterprise resources that should be protected and preserved at any cost. So, as you work through the many threats that are there, right? Think about the vulnerability and the exploit that makes the threat possible. Notice how many different parts of the enterprise network exhibit the vulnerabilities and how the threats are crafted so that we can take the advantage of the weakness. Right now, like this first one, attacks that spoof addresses. Right. So what we have different attacks where we are doing what we are spoofing the IP addresses, or we are spoofing the calls, ARP spoofing, GPS spoofing, different types of spoofing we are doing, right? So, what is spoofing? So, when the systems they behave normally, parameters and services can be trusted and they can be used effectively. For example, when a machine sends an IP packet, everyone expects the source IP address to be machine's own IP address, and the source MAC address in the Ethernet frame is expected to be the sender's own MAC address. So even services like DHCP and DNS should follow the suit, right? So if a machine sends a DHCP or DNS request, it expects any DHCP or DNS reply to come from a legitimate server. Now spoofing does what? Spoofing attacks focus on one vulnerability. Address and services they tend to be implicitly trusted. So attacks they usually take place by replacing expected values, right, with spoofed values, or we can also call them fake values. So address spoofing attacks they can be simple and straightforward, where one address value is substituted for another, right? So what an attacker can do, uh, let me paste a picture for you guys. So when the target, and what attacker can do, attacker can send packets with a spoofed source IP address instead of its own. And when the target receives the packets, it will send traffic to the spoofed address rather than attacker's actual address. So if the spoofed address exists, then an unsuspecting host with that address will receive the packet. And if the address does not exist, the packet will be forwarded and then dropped out further in the network. An attacker can send spoofed MAC addresses too to add false information to the forwarding table, which is used by the layer 2 switches, or ARP tables used by the other host and routers. DHCP servers or DHCP requests with spoofed MAC addresses can also be sent to a legitimate DHCP server, which will fill its address least table, and there will be no IPs left for normal use, right? That is also there. Then what other attacks are there? Denial of service attacks. Now, what is denial of service attack? Multiple requests to break the bandwidth. So, yep, what I'm doing, I'm sending a lots and lots of data from a single device to make the system or make the website vulnerable, right, for other users, or make the website non-available for other users, right? But the thing is, can we do it on websites only or networks only? Can't we do denial of service on other places, different places? We can do it, right? Now, is denial of service attack done nowadays? Correct. Bots are used for DDoS. Now, denial of service attack means I'm sending my data from one single system, right? So, what firewalls do? What is the work of firewalls? Firewalls, they will block the data, block the incoming data, which is coming from a lot of data, which is coming from a single source, right? So, if I'll send lots of data to a website from my source, my IP will be blocked or my packets will be blocked, right? So in distributed denial of service, what happens? Attackers, they take access of multiple systems, right? This is one system, right? This is second, third, and thousands of systems they are taking access of, right? You don't even know if your device is being used in an attack or not, right? Now, attackers, when they take access of these systems, so from all these systems, they will send the data to the website or any network, right? So when I'm doing this to a single server or single target, right, which is this, right? So this target will be down, right? It will be DOS, so it will not be available if a new user arrives and that user says, I want to access the website, so it will show the website as unavailable. Yes, so that is denial of service and distributed denial of service. Can you see there is the attacker and there is a corporate server which is being called as a reflector, right? So in spoofing attack, what we are doing, attacker sends packets with a spoofed source address to the target. Now the goal is to force the target to deal with the spoofed traffic and send return traffic to a non-existent source, right? What does that mean? What the statement of mine means? Do you guys know what is three-way handshake? Now, when we are talking about three-way handshake, so what happens whenever any TCP communication starts, whenever two devices are communicating over TCP, right? So these devices, what they do, they first communicate or they perform three-way handshake. So whenever a legit TCP communication starts, it's always starts with a three-way handshake, whatever it is. So there are flags in TCP, right? So user one sends a SYN flag. SYN means synchronization, right? So the user wants to synchronize with the user two. He wants to know who he is, right? Then user two replies back. What is the reply? SYNAC, right? So basically, user one is saying that hello, user two, my name is user one, this is my identity, save it. User two says, hello, user one, this is my identity, and I acknowledge that I have saved your identity, right? User one says, thank you, and I have also saved your identity, right? That is what happens in three-way handshakes. Send, send, ack, and acknowledgement flag. These three flags are sent, two flags, right? That is how communication happens. Clear? Now, in reflection or amplification attack, the goal is to force the target to deal with the spoof traffic and send traffic towards a non-existent source. Now, the attacker does not care where the return traffic goes or that it cannot be believed successfully, right? So, in a related attack like this, the attacker again sends packet with a spoofed source address towards a server, like in the image you can see, right? Now, however, the host is not the intended target. Then who is the target? This person is the target. So the goal is to get the host to reflect the exchange towards the spoofed address that is target, and that is known as reflection attack, right? So think of it as a sandwich corner, right? There is a shop. So now what I am doing, I'm not directly attacking, right? I'm reflecting someone. So in a sandwich shop, what you did, you told fake news to all the people nearby that they are giving 70% off. So it will be a lot of rush over there, right? Lots of people will be going in the sandwich corner. They will be just having orders and orders and everything, but they are not giving that 70%. So they are filled. So I have reflected the audience towards that sandwich corner, right? Same like that, I'm sending some data. Being an attacker, I'm sending the data from my system, but I have spoofed the IP address of someone else. So I sent the request, the messages to the corporate server. Now, where the server will reply back? It will reply back to the IP which was written in the source, right? So it will reply back to the IP 198.51.100.254, which is actually the IP address of this user. And that's how this user got attacked. This is reflected attack. Now, instead of this, can I do one thing? Instead of sending the request to only one reflector, I can send the request to multiple reflectors so that this victim or this target will receive multiple copies of unexpected traffic. Yes. Now, the impact of reflection attack, it might seem limited because a single target host is the victim, and the amount of traffic being reflected to the target is in proportion to the packets which are sent by the attacker. So if an attacker is able to send a small amount of traffic to the reflector and leverage a protocol or service to generate a large volume of traffic toward the target, then it will be called amplification attack. Now this attack does what? It amplifies the attacker's effort to disrupt the target, right? So another result is that the large amount of network bandwidth can be consumed, right? Forwarding the amplified traffic toward the target. If many reflectors are involved, some of this can happen, right? Now, some of the mechanisms like DNS and network time protocol, they have been exploited uh, in the past to set new records for enormous bandwidth consumption during an amplification attack. Great. So, if I show you something related to the DOS attack, let's see if it is there. Okay, so there is a tool, uh, goldeneye.py, right? Now, what if I do one thing? I'm making my Kali Linux. This is my Kali Linux operating system. So I'm making this Kali Linux operating system as a server, right? Now, once it is a server, let's give here HTTP slash slash 192.168.175.147. This is the IP address of my Kali Linux, and I'm saying -s 500 sockets, right? So it says hitting web server in a mode get with 10 workers running 500 connections each, right? So every user is creating 500 connections each, right? Now, in real, what should happen? I should be able to open the page of the Apache, right? So the page of Apache should be openable, right? But let's say if I write the IP of my Kali Linux in the browser 192.168.175.147. Let me change the settings. Just a setting. Now, if I try to open it, I have written the IP in the browser and the in my for searching for opening the page, but the page will open very late. Why so? Because at the backend a DOS attack is happening on it. See, it opened very late. And after some time you will see it will not even open. Yes? Okay, let's try to open it again. 192.168.175.147. Right? So can you see 171718 golden eye strikes hit, 0 failed. So it is working, right? You can start it with more like 5,000 connections, right? So it is running 10 workers running 5,000 connections each. So one worker will start 5,000 connections. So that will be a total of 50,000 connections being made to my Apache server. Now next is man in the middle attacks. What do you mean by man in the middle attacks? Now let's say I want to do man in the middle attack, right? So I'm using a network analysis tool, Wireshark, right? Now we can hear all the requests which are going from my device to other device, from what source to what destination, what requests are going, how the traffic is traveling, everything, right? So if I write here ping hyphen c10 and let's do it on 192.168.29.230. Just let me check the IP address, which one to use. Now, if you can see here, every kind of request is being captured, everything. So, can I call it man in the middle attack? See, here is the ping request from 147, my device, to 29.238, which is the IP address of my mobile phone. It is going there. Yes, perfect. So, that's what we call man in the middle attack, right? So many types of attacks, they are meant to disrupt or directly compromise target systems, right? Often with noticeable results. Sometimes attackers might want to eavesdrop on the data that is passing from one machine to another and avoiding the detection. So a man in the middle attack does that, just that, by allowing the attacker to quietly wedge itself into the communication path as an intermediary between the two target systems, right? So one type of man in the middle attack, it exploits the ARP table that every host maintains to communicate with other hosts on its local network segment. So if one host needs to send data to another, what it does, it looks for the destination in its ARP table. If an entry is found, the Ethernet frame can directly be sent to the destination MAC address. Otherwise, the sender must broadcast an ARP request which is containing the destination's IP address and wait for the destination to answer an ARP reply, right? So how it looks like, let me paste a picture. Now in this we can see in this request it says uh, 198.51.100.10 ARP request goes who has 198.51.100.10, right? Now that ARP request goes to everyone, right, in the network. Now the server's IP address is 198.51.100.10, but there is an attacker sitting, and attacker says that my name is 192.168.100.10 and my MAC address is 000.aaa.aaa, right? And attacker sends that information to the client. Now what client does? Client will send the data to the attacker directly, right? So that is also happening in man in the middle attack. Perfect. Then there are reconnaissance attacks. What do you mean by the word reconnaissance? What is reconnaissance exactly? So reconnaissance, guys, it means information gathering. Yes. And reconnaissance attacks, why they happen? Why you need information? You need information of the organization because to attack further, right? Attackers, they use the information gathering techniques to find out the IP address of the organization, right? What IP address ranges internally they are using, fully qualified domain names, right? So that they can perform the further attack, they can further find out what the things are. Yes. Now, let me show you one thing, that what is the easiest way of doing the reconnaissance, right? Let's say there is NS lookup, right? So what you have to do, you have to give an IP address or a domain name, right? Let's say I'm giving 19, or this is in the IP address 206.223.165, right? You got the name, right? If I write Amazon.in, you got the IP addresses of Amazon.in which are being used, right? Isn't this a part of information gathering, right? Then can I do who is lookup? Now what who is lookup is, right? Let's see the whois.com, right? And if I find out information here, let's say about InfoSecTrain.com. So here what we can see the domain name, right? The registrar information, right? Registrant contact, administrative technical contact, raw data of who is, right? Everything. Now more detailed information you can find out on Netcraft. There is a website Netcraft. Now if we start Netcraft, and if I write info16.com here, Okay, not here. Let's search this one. Now here, if I write infosectrain.com, right, and do the lookup, so what information you are expecting? Now, it's showing operating system as Linux and web server as Lightspeed. Yes. Then, apart from that, the IP address. Yes. Now, there is an extension that I use for gathering more information, and it is with the name Webalizer. So, any website I visit, let's say I'm visiting the website of EC Council, right? Once the website is open, right, at the top right, you will see a number written. Can you see on my browser at the top right, a number is written? Now, let's see this, what it is showing. It's showing the name Webalizer and it is showing me the technologies. So can you see? So all these technologies that you can see, these are being used by the IC Council website. Now, let's say you get to know the version of some website. Let's say here you can see jQuery 3.7.1 modernizer you are using. They're using 2.6.2, Bootstrap 3.4.1, right? So you can find out the exploits for them over the internet and see if they are exploitable or not, right? So those are what? Those are known as reconnaissance attacks, right? Now, the next thing which we have is malware. What is malware, guys? How will you define? Anyone? Malware? What is malware? So, malware is a word which is made up of two is malicious software, right? Now, malicious software means any software which is there with an intent to harm. Yes. Now the thing is, there are different types of malwares present. Like you might have heard of virus. What is virus? Every malware is nothing but a piece of code. Yes, which works as the code is written. Instruction it is. It is an instruction to the computer, and whatever is written in the instruction, the computer will work same. Yes? Perfect. Now, is virus an acronym or is it a word only? Just a word. So when we are talking about virus, virus is an acronym which stands for Vital Information, right? So what it does, virus is a piece of code which will infect your files inside the system, but it cannot travel over the network, right? Say at the same place there is worm. Worm can do what? Worm cannot travel over worm can travel in over the network, but virus cannot, right? Then there is one more which is known as Trojan horse, right? Now Trojan horse does what? Whenever you hear the word Trojan horse, always remember there is backdoor, right? So it gives the access to the system. It opens the back door for the attackers. Then there are human vulnerabilities as well. Human vulnerabilities means social engineering, right? Now when we are saying social engineering, anyone who can tell me? Social engineering. So it is an art, right, of making people fall in the trap, trying, and you can try to take information out of the people, right? Convincing people to share the information, right? So many of the calls you might have received, right? Fake calls where they say your credit card has been blocked, and for getting your credit card back, for renewing it, you just need to validate it, right? And just give us the 16 digit number and everything to me, and then I will renew it, right? So that is what that is social engineering, right? So human, that is human based vulnerability. From humans, you are gathering the data, right? Now, let's say, let me show you a practical for that, right? How attackers do, just a normal, simple practical. For that, I will be needing some of the email IDs, right? So you guys can drop your email IDs privately to me in the chat and then see if there is any email received. Okay, so this is known as social engineering. All those who drop their email IDs in the chat, right? I got your email IDs now, right? This is I convinced you in a way by which you dropped your email IDs, right? So this is convincing. I convinced you to share your email IDs and you guys shared it with me, right? That is also social engineering. Then I can give you lots of reward points. Let's say if I say that I'll give you some reward points and you have to give me your email ID, you have to click on this link. So let's say I'm sharing a link with you, right? It's not a malicious link. And let's say you guys are using Netflix, right? So I will ask you that if you have the premium account of Netflix, you'll say no. or yes, we do have, but we pay for it. I'll say that you can upgrade your Netflix plan to free, right? Just by clicking on this link. Now, on this link, the first thing that you will see is HTTPS. Yes, it is HTTPS, right? Now, click on this link. The website will be looking same as Netflix. Check that out. Then I'll tell you how to make it. Now, if you see here in the right hand side, I have the IPs of all of you guys who clicked on the links, right? And the username and password that you have entered, right? So once you just click on the link, your IP is with me, right? So that is how attackers they make you fall in the trap, right? Now this is just a small view of things, but the attackers what they do is they generally uh, create, or we also do that in the organization whenever the red team exercise happens. So we have to also create or perform a phishing and phishing campaigns we have to start, right? So that is what that is social engineering, and those are human based vulnerabilities, right? Then we have password based vulnerabilities, right? Now, most of the systems in an enterprise network they use some form of authentication to grant or deny user access. When users they access a system, a username or password are usually involved, and it might be fairly easy to guess someone's username based on the person's real name. If the user's password is set to some default value or to a word or text string that you can guess, an attacker can easily gain access to the system, right? Let's say you are using the password as a password 123 or 12356 you have your own date of birth as the password, right? Sometimes like in many of the routers it is seen that the password is admin, right? So what attacker can do, attacker can launch an online attack by entering each password guess as the system prompts for user credentials. And an offline attack occurs when the attacker is able to retrieve the encrypted or hashed passwords ahead of time. Then he goes offline to an external computer and uses software there to repeatedly attempt to recover the actual password, right? Then attackers can also use some tools like there is a tool with the name Hydra or Medusa, right? Ncrack is also there, right? To perform the brute force attacks on the target, right? So dictionary based attacks can also be done, right? So those username and password uh, attacks they can be done, right? Now the next thing that we have to discuss is about DHCP. Now, when we are talking about DHCP, as we know, it assigns IP addresses, but how? So, DHCP, it stands for Dynamic Host Configuration Protocol, and it provides one of the most commonly used services in a TCP/IP network. The vast majority of hosts in a TCP/IP network, they are user devices, right? And all the user devices, they get their IP information settings using DHCP. Right. Now, using the DHCP will have like several advantages over the other options. Manually configuring IPv4, not possible, right? So, DHCP does this automatically, right? Now, what happens? The process of DHCP, DORA happens, right? First, discover request goes, right? So the client does what? It is a client send a discover request to a willing DHCP server, right? Now the DHCP server offers to lease an IP address to a client, right? And it also tells other information related to the IP address to the client. Then request. So it is sent by the DHCP client to ask the server to lease the IP address which was there in the offer message. Then DHCP send acknowledgement, right? So it is to assign the address and list the mask, the default router, and the DNS server IP address, right? So this DORA process happens that this now this IP belongs to you. Yes. So this is the process of DHCP and this is how you get the IP address in your system, right? The next thing we are going to discuss about is quality of service. Now, when we are talking about quality of service, we all know about routers, right? So routers they sit at the WAN edge, wide area networks edge, right? With both WAN interfaces and LAN interfaces. So my network inside is a LAN, then that whole LAN is connected to the router and router is connected to the wide area network, right? So those local area net interfaces, they typically run at a very much faster speed, and WAN interfaces they run at a slower speed, right? So while that slower wide area network interfaces, they are busy sending the packets, waiting in routers, hundreds or even thousands more IP packets could arrive in the LAN interfaces, all needing to be forwarded out that same WAN interface, right? So what should the router do? Send them all in the same order in which they arrived, or prioritize the packets to send some earlier than others, or preferring one type of traffic over another, right? So QoS is what quality of service refers to the tools that networking devices they use to apply some different treatment to packets in the network as they pass through the device. For instance, let's say the wide area network router, edge router, would it will queue the packets waiting for the wide area network interface to be available, right? So it can use a queue scheduling algorithm to find out which package should be sent next using some other order than the arrival order, giving some packets better service and some as the worse service, right? Now, the thing is, we have the types of traffic in WAN, in QoS. So all the tools in QoS they give you means to manage four types of characteristics of network traffic, right? Bandwidth, right? So bandwidth is what? Speed of the link in bits per second, right? But when we are thinking of bandwidth at speed, so it helps to also think of bandwidth as the capacity of the link. How many bits can be sent over the link per second, right? So I will say the amount of information that can be broadcast at a specific time is known as bandwidth, right? Then there is delay. What is delay? It is described as one-way delay or round trip delay, right? One-way delay refers to the time between sending one packet and that same packet arriving at the destination. Round trip delay counts the one-way delay plus the time for the receiver of the first packet to send back a packet, right? So we can call it the time it takes to send one packet between two devices and receive one back, right? So that is delay. Then there is jitter. What is jitter? It is one-way delay between two consecutive packets. So two packets arrive, one is giving me 5 ms, one is giving me 3 ms, so the jitter will be 2 milliseconds, right? That is the meaning of jitter. Then finally the thing is loss. Loss refers to the number of lost messages, right? So percentage of packets sent and how many received. So let's say I sent 100 packets and 98 were sent. So there was a 2% loss, right? That is the meaning of loss, right? Now next thing in quality of services, data applications. So when we are talking about data applications, let's consider that there is a web application. So a basic web application with a user at a PC or tablet, the user types the URI, right, to request a web page. The request may require a single packet going to the web server, but it may result in hundreds or thousands of packets coming back to the client, right? So what is the impact of bandwidth, delay, jitter, and loss on an interactive web application? First, the packet requires a certain amount of bandwidth capacity. Yes. For delay, each of those packets from the server to the client takes some amount of one-way delay with jitter as well, right? So QoS tools, what they do, they focus on managing these bandwidth delays, jitter, and loss in web browsers and web applications as well. Now, when we are talking about QoS on switches and routers, right? So how it works? What it does on switches and routers, the quality of service, it will basically help you manage and optimize the data flow, and it will prioritize the network traffic, right? And it can be implemented both on switches and routers. So it is a factor that what kind of application is it, it is the source, the destination where we are sending. On those basis, the traffic will be prioritized, right? So apart from then the queuing will happen, or traffic shaping will happen, then the data traffic will be forwarded on those bases, right? That is on switches and routers, right? Now, next thing that we have is controller based networking, right? So, what is controller based networking? Okay, so now what happens, like there are networking devices, right? So, those networking devices they forward data in the form of messages, right? Like data link frames, like Ethernet frames, right? So, we have learned how switches and routers they do the forwarding, right? So network programmability and software defined networking take those ideas and analyze the pieces and finds the ways to improve them for today's needs and reassemble those ideas into a new way of making networks work. Now at the end of that rearrangement, the devices in the network still forward messages, but the how and why have changed. Right? Now when we are talking about this thing, the programmability. So there are some things which are known as like there are planes, basically the data control and management plane, right? So think about what networking devices do. What does a router do? What does a switch do? Many ideas should come into your mind, right? So routers and switches physically connect to each other with cables and with wireless to create networks. They forward messages and they forward Ethernet frames, and routers forward the packets, and they use many different protocols to learn useful information like routing protocols and network layer routes. Everything that networking devices do can be categorized as being in a particular plane, right? So when we are talking about data plane, it refers to the task that a networking device performs to forward a message, right? So anything to do with the receiving data, processing it, forwarding the same data, whether you call the data a frame, a packet, or a message, that is the part of data plane, right? So in this image, you can see like what is happening. It is showing how routers they forward IP packets. So if you focus on the layer 3 logic for a moment, the host sends the packet to its default router, and then this router 1 does some processing on the received packets and makes a forwarding decision and forwards it to the router 2 and then to router 3, and they also receive and process the data forward and then to router 4 and to the switch, right? Now, broaden your thinking for a moment. Try to think of everything a router or switch might do when when they are receiving and processing and forwarding a message. So the forwarding decision is the part of logic. So the data plane is often called forwarding plane, right? Yes. So that is the meaning of data plane. Then the next thing that we have is control plane. So control plane, now think of it, the kinds of information that the data plane needs to know before so that it can work properly. So router needs IP routes in a routing table before the data plane can forward packets. Layer 2 switches, they need entry in the CAM table before they can forward Ethernet frames out of the best port to reach the destination. Switches, they must use spanning tree protocol to limit which interfaces can be used for forwarding so that the data plane works well and does not loop, right? So from one perspective, the information supplied to the data plane controls what the data plane does, right? Whatever information they have. So a router needs a path that matches a packet's destination address for the router to know how to forward the packets. And when a router's data plane tries to match the routing table and finds no matching path, the router will discard the packet. So what controls the contents of routing table? Lots of control plane processes, right? So the term control plane, it refers to any action that controls the data plane. And most of these actions have to do with creating the tables which are used by data plane, tables like IP routing table, ARP table, switch CAM table in the switch. So by adding to removing and changing entries to the tables used by data plane, the control plane processes control what the data plane does. Yes. And then comes the management plane, right? So the control plane performs overhead tasks that directly impact the behavior of data plane. Management plane performs overhead work as well, but that work does not directly impact the data plane. So instead, the management plane includes the protocols that allow the network engineers to manage the devices, right? Like there is a service SSH and Telnet. Yes, these are two of the most obvious management plane protocols. So the difference with control plane protocols, and to emphasize that difference, think about two routers, right? One router is configured to allow telnet and SSH into the router, right? So this one allows SSH and telnet, other one does not, right? But both could still be running a routing protocol and routing packets, whether or not they support telnet or SSH. We have is REST and JSON. What is REST? What is JSON? and how they can be used. API stands for Application Programming Interfaces. Right. Now, applications they use APIs to communicate. So one program can learn the variables and data structures which are used by another program, right? Making the logic choices based on those values, changing the values of those variables, creating new variables and deleting variables. So APIs they allow the programs running on different computers to work cooperatively, exchanging data to achieve some goal, right? So in an API software world, some applications they create an API with many other applications using the API. So software developers, what they do, they add the API to the software so the other application software can make use of the first application's features, right? So when developers they are writing application, the developer will write some code, but often the developer may do a lot of work by looking for APIs, which can provide the data and functions, right? Which reduces the most amount of new code that must be written, right? So as a result, modern software development centers on understanding and learning new APIs along with available libraries work, right? So there are lots of APIs that are used. First one that we have is REST API, right? So REST APIs follow a set of rules, right? About what makes a REST API and what does not. Yep. Now REST APIs they have six attributes. First one is client server architecture. So if we can see this image, right? Like many applications, REST applications, they use a client server architectural model. So first an application developer creates a REST API and then that application when it is executing acts as a REST server. Any other application can make a REST API call by executing some code that causes a flow of request, right? So here if we can see the REST client, this is the REST client, right? So REST client executes a REST API call which generates a message sent to the REST server, right? Then the REST server has a API code that considers the request and decides how to reply back. Yes. Now the REST server sends back the reply message with the appropriate data variables in the reply message, right? Then next one, stateless operation. So the stateless attribute of REST API means that REST does not record and use information about one API exchange for the purpose of how subsequent API exchanges are processed, right? In easy words, I can say each API request and reply does not use any other past history considered when processing the request, right? Then cacheable or not. So what is meant by cacheable? So what happens when you browse a website? When browser loads a new page, the page itself contains a variety of objects like text, images, videos, audios. Some objects they change, so it would be better to download the object once and not download it again. So in that case, server marks that object cacheable, right? Any logo or any other image which is shown on many pages of the website would almost never change and it would likely to be cacheable, right? So the product list written in your most recent search of the website would not be cacheable because the server would want to update and supply a new list each time, right? That is cacheable, right? Next is REST APIs and HTTP. Do they work with each other or not? API exists to allow two programs to exchange data. Some API, they are designed as an interface between programs which are running on same computer. So the computer uh, communicate between programs within a single operating system. Many APIs, they need to be available to the programs that run on other computer. So the API must define the type of network protocols which are supported by the API. And many REST based APIs, they use the HTTP protocol, right? Now, why the creators of REST API, they often choose HTTP, because HTTP's logic matches some of the concepts which are defined more generally for REST APIs. So it uses same principle. It operates with a client server model. It uses stateless operation model, and it includes headers. And that clearly marks objects as cacheable or not cacheable, right? So that's why HTTP and REST APIs are used with each other, right? Next we have is JSON. What do you mean by JSON? Now, JSON does what? JSON stands for JavaScript Object Notation, right? So it attempts to strike a balance between human and machine readability, right? And there are some JSON rules. So most humans can read JSON data, and they move past simply guessing at what it means, and confidently they interpret the data structures which are defined by the JSON data. So JSON data, it makes it easy for programs to convert the JSON text into variables, and it makes it very useful for data exchange between applications using APIs, right? That's why JSON is used. Next is XML, extensible markup language. So in 1990s, when web browsers and the World Wide Web were first created, web pages, they used HTML to define web pages as a markup language. So it defined how to add the text to, or a web page to a file, and then adds markup, additional text to denote formatting details for the text that should be displayed, right? Now, XML came later to make some improvement for earlier markup languages, right? So in particular, over time, web pages, they became more and more dynamic. And to make the pages dynamic, the files needed to store variables whose values could be changed and replaced over time by the web server. Yep. So to define variables to be substituted into a web page, the world needed a markup language which can define data variables. So XML has many features, right, where you can define variable values and data structures. But according to the data, you can do what? You can define the variables. So if it is integer, you can just write int. There are no defined tags like HTML. You can create your own tags in XML, right? That is XML. Now there is YAML. So YML is what? It has a recursive name, but the name tells us something. YML does not attempt to define markup details. YML focuses on the data model. That means structure, right? So YML also strives to be clean and simple of the data serialization modeling languages, right? And YML is easily the easiest to read for anyone new into data models, right? So in Ansible, your YML is used, right? So we have to understand Ansible. What is Ansible? So to use Ansible, you have to install it on some computer like Mac, Linux, or any Windows host, right? You can use the paid version, uh, Ansible Tower server version, or you can use the free version installed. So once it is installed, you create several text files like playbooks, right? So playbooks, they provide actions and logic about what Ansible should do. Then there is inventory as well. Now inventory has these files which provide device hostname along with information about each device, like device roles. So Ansible can perform functions for subsets of the inventory. Templates are also there, like there is a language Jinja, right? So using Jinja 2 language, the templates represent a device configuration but with variables, right? And at last, variables. So using YAML, a file can list variables that Ansible will substitute into templates. Then we have Puppet as well, right? So Puppet can be installed on Linux, right? So it is free and open source version as well, and there is a paid version also. Now in Puppet, there is Manifest, right? Manifest is what? This is a human readable text file on the Puppet master. Yes. So it is saved on Puppet Master using a language which is defined by Puppet and used to define the desired configuration state of a device, right? Then there is there are resources, class, and module, right? Right. So these terms refer to components of the manifest, with the largest component is module, being composed of smaller classes, which are composed of resources, right? Then there are templates as well, right? So using a Puppet domain specific language, these files allow Puppet to generate manifest, right? And modules, classes, and resources by substituting variables into template. Then the last one you have is Chef. Heard of Chef? So Chef, as with Ansible and Puppet, exist as software packages that you need to install. Chef offers different products, with Chef Automate being the product that most people refer to simply as Chef, right? So in Puppet, like in production, you probably run Chef as a server, right? With multiple Chef workstations, which are used by engineering staff to build Chef files that are stored on a Chef server, right? And you can also run a Chef standalone mode, which is called Chef Zero, and it is also helpful when you are just getting started with it, right? So what Chef has, like let's say it has resource, right? So the configuration objects whose state is managed by Chef, for instance, a set of configuration commands for a network device, right? Then there is recipe, right? So the Chef logic applied to resources to determine when and how and whether to act against the resources, right? So it is analogous to a recipe in a cookbook, right? Because there are cookbooks as well, right? So it is a set of recipes about the same kind of work which is grouped together for easier management and sharing. And then there is run list. So run list, it is an ordered list of recipes that should be run against a given device, right? That is Chef, right? Now, one example of chef, if I show you, that we generally use, it is cyber chef. Now, here you can see recipe input output. Now, if I search for any operation, let's say parse IP range, right? So, if you have to create a list of IPs, right? What you will do, like I will write 192.168.175.0/24, right? First, let's choose this. And I've the recipe is parse IP range. I've given the input 192.168.175.0/24 and it gave me the list of all the IPs that are there, right? So rather than writing them by your own, you can use it, right? So lots of things are there that you can use in this chef, right? So that's it for the CCNA accelerator, guys. And thank you so much. I hope you guys learned some new things during this whole course. And thank you so much. If you have any questions, you can let me know, guys.